Hi everyone, I hope you are doing good. So today we will take a new question here, and in this video first we will understand the question here, right? And then we will talk about the algorithms, the approaches, what can be applied here to solve this question. And then we will see the code also. I'll implement this algorithm, whatever we will discuss, into the C++ code, and then we will run the multiple use cases there, and we understand this complete question and answer, right? So let's start with the question. So the question is given here, a grid of n cross m. So we will get a n cross m matrix here consisting of O's and X, right? So that matrix will have the O and X, and then the task is to find the number of X total shapes. So we will have the shapes in that matrix, and that shape consists the X, and the rule is here is not X shape consists of one or more adjacent X, right? Diagonal not included. So for example, so this X will be considered as a shape, right? But in this case, for example, we have n cross m, right? So this one. So this will be considered as a one shape. Why? Because it is saying X shape consists of one or more adjacent X, right? So this X is adjacent to this one, right? And this X is adjacent to this one, and this X is adjacent to this one, and this X is adjacent to this one, correct? So all are connected to each other, right? Either horizontally or vertically. Here we are excluding the diagonals, right? See, carefully understand the question here. So here it is mentioned explicitly कि diagonals not included. So we will not include the diagonal. We are either the X should either connected by the horizontally or vertically. That is what we have to consider. Okay, let's understand this question with example. So let me remove this one here first. So this is the given grid basically, right? And in this grid we have to find the number of shapes, right? So if we follow the rule, then you see here, so this would be one shape because this is left side is boundary, right? A top is boundary, and the right side we have O, right? And below is also O, right? So here if we go left like horizontally or vertically, then we get this is the one shape, correct? So here or count would be 1, correct? Now again go next, then we will check for this one. This is O, so this is not, this cannot be a shape, right? Then third one we go here with this index, and this is here we have one more X, right? This is left side having O, below is having O, right, and up is having boundary of the grid. So this will be considered as a shape. So one shape is this one. So now the count is 2 here, right? And then the third one is O, and the fourth one is X, right? Left is having O, right, up is having O, right? Right is having O, but below we are having X. So this X is connected to this one, correct? So now we will check for this X. This X is having left X, so this is connected to this one, right? And right is having X, so this is connected to this one. So now this will be considered as a one shape here. So this is the rule, correct? So now see here, we have three shapes. So now we have three shapes. So our answer should be 3 in this case. So this is the question. I hope you understood this one. This is the question which we have to solve. So this is the given example, right? We did the dry run for here. So now we have to find the algorithm. We have to find the solutions, efficient solution basically, to solve this kind of questions. So now pause the video for 3 seconds and then think about it. Just pause the video for 3 seconds and think about the solution, think about the algorithms, and comment it below the video so that we also get to know what you are thinking. So let me explain what I am thinking here.
3, 2, 1, go.
So I am here using the iterative plus recursive both, right? For iterative, the algo I am using to iterate through the complete matrix, and for recursive, I am finding the connected X basically, right? So this is this one is the iterative one approach here, and from here I have added one function here. This is basically recursive function here, this one, and this is finding the connected nodes, right? Connected X, and this is basically checking for each and every node. Yeah. So see here X, right? So what I'm doing here, I'll start from the first node here, right? 0 comma 0 value. See, you know about the 2D where we have the X value and Y value, or you can say row value and column value, right? So here the first row, right, zeroth row and zeroth column, so we will check for this value. Now we will pass this value x to the this functions where we will find the update connected x shapes to O, right? So what this function is doing here, it is basically checking for the x value. So first it will check if x value is like valid value, valid position. If it is valid position, then what we will do, this is what we will do, we will make this value to O, right? So now after this, what will happen after this one? So this will be considered as O now, and then we will check for the left value of this one, right? Left value of this one. Then we will check I plus 0 and I plus 1, j plus 1, right? J plus 1 means whatever the j value. So here j value is 0, a I j, right? So I is 0, j is 0. Now we have updated this value, zeroth position value we have updated to O, right? And then we will check for the I0, I comma j plus 1 basically, right? So I would be 0 and j would be 1 here, right? And in that case this value. So this is O value, this is not X, this is not a valid X value, right? So here what we have added one check here, right, for base condition for recursive functions, where if either I is out of bound, like crossing the boundary, or it is O, in that case we will return from here itself. So see here, grid of I comma j is O, so we will return. So we will come back from here, we go here and we will come back here, and then we will check for the next value. Next value is this one. So here the rule which mentioned explicitly there, we have to consider only horizontal and vertical, means we can go up, we can go down, we can go left, we can go right, we cannot go diagonally, right? So that is why I have taken here four calls only. So first I am checking for the right side, then I am checking for the downside. Here see I plus 1 and j plus 0, right? This 0 I am adding for understanding purpose only, you can like leave it, you can directly say j only, right? So because j plus 0 would be j only. So here I plus 1, so I would be here 1, j would be here 0. So here the 1 comma 0 is this one, right? So this is 0. Let me mark the number also, 0, 1, 2, and this would be 0, 1, and 2. Correct? So now here this would be O, right? So here also it will return. It will go here and it will come back here, and when it will go for the left side here, I minus 0, j minus 1, right? Means I comma j minus 1. So when we will do j minus 1, j is 0 initially, so it would be minus 1, correct? And I would be 0 only. So 0 comma minus 1, that is going out of bound, so we will return. So we will go left and we will return, and same we will go for the up also, right? So here this would be one shape here. As soon as x encountered, we will increase the or count. So we can say here or count is 1, correct? Now we will return from this function, this where we are updating the connected x shapes to O, right? So this is the function which is basically updating the visited nodes. So now count is 1 here, and now we have checked for this position, right? All the connected nodes we have checked, and now we will go come back from here, right? From this function we will return here, and we will check for the next position basically here. So this position, one position we will check, this, that is O, that is not X. See, we are only checking for X here. So this is O, so we will not do anything. We will go next. Then this is X. Now this is again X. So what we will do here? So let me remove this one here, and we have count is 1 already, right? So for this 0 comma 2 position, we will update the connected x shape to O. So what we will do here, for this one we will call this recursive function here, and it will check for this base condition. It is not, so then it will go down and will update this one. So this will be, this x will be updated to O, correct? And then it will check for the this right side. So right side is nothing there, right? Then it will check for the down. Down is also O, so it will come back, and then it will check for the left side. Yes, left side is O. Then it will check for the up, right? So there it will also return, because that is also the boundary. So this is also not having any connected nodes, right? So it will update itself and then it will return basically this function. So now the count is a 2. Correct? So count we will increase initially only. Then we will come back here, and then we will check for this node. This is O, so we will not do anything from this loop, right? Then we will check for this one. Yeah, this is the X. So this is X, so we will update the count. So count would be 3. correct? And then we will update the we will call these functions which will update the connected nodes to O, right? And this will check the first, it will check right side, right side is O, so it will come back. Then it will check the down, that is I plus 1, correct? So here it will go and see here it is X, so it is X, it is not fulfilling this condition, so it will not return, it will go down. And here it will making this one, this condition is this is updating the I comma j value, so it will also making this one to O, correct? And now this is calling for this one. Now the same call will get called for this one, and it will check for the right of this one. Yeah, this is X. So it will also get updated to O, and it will call for this one. So here we have nothing. We have boundary. So we will come back. Then we will go down. That is also boundary. We will come back. Then we will go left. Left already we have updated to O. So we will come back, and we will go up. Up is also O. So we will come back, right? And here we will after checking all the directions, we will come back to this O. And then this is also we have like went to right side, so now we will check for the down for this one. Nothing is there, the boundary is there, so we will come back, and then we will go to left here. So left is also having X, right? So it will also get updated to O here. And we will check for this one then now, correct? So here right is already updated, so it will come back here. Then we will go down. Down is also boundary, so we will come back here. And now here we will go left. Left is boundary, so we will come back here. We will go up. That is also O, right? So we will come back here, and then this is done. So we will go back to the previous one. Previous one is O. This is also done. So now we will go to this one up here, right? And for this X, now we are done for all the connected nodes. So now we will return to the main function. Main function means this main function here, where we are counting the recursive like the shapes, correct? So it will come back here, and then again it will go for the next basically next position, correct? For this one, this is O, right? So we will not do anything. Then it will go to this position here. So let me change. So it will go to this position here, correct? And this is also updated to O. Nothing is, we will not do anything. Then it will check for this one. This is also O because it got updated, right, in the previous call. So we will not do anything, and this is also O. We will not do anything, and we are out of the, like, we have traversed the complete matrix, right? So I hope you understood here the count. Now we are out of this one, and then we will return the result whatever we found. So the result we found is 3, correct? So here we have calculated like we have 3 shapes in this given matrix, correct? I hope you understood it can be done. So this part, the second part, where we are updating the basically visited nodes, so it can be done using the separate matrix also, where we can maintain instead of updating the given matrix itself, right? So basically it can be done using the separate matrix where we can update the visited nodes, right? So this is the second approach. So you can have an approach like one is you can take first this one, this matrix, right, separate space. Then if the interviewer asks you to optimize this one, kind of in case of the space also, space optimization, then we can avoid this matrix also, separate matrix. We can update the same matrix, and we can go with that solution whatever we discussed, right? So that is the thing. And for this one, like for example for this x1, right? So for this x1 this is false, so we can count this one as we can consider this in count, so we will increase the count 3, and we can say this is true, right? And then this is O, we will not do anything, correct? Then we will go down. So down is X, right? Down is X, and this is not visited, so we can also mark it visited. And for this one, this X, we will check left and right. So left is false, and X, so it is the X is value, and it is not visited node. So and this is connected to this one, so we can mark this one, and then we can also mark this one. And kind of then again we will go for the this one. This is O, will not do anything. This one, this is already true, visited node, so we will not count it. This one is also visited, right? True, so we will not consider this in count. And this is also visited node, so this will not be considered in the count. So here also I wish you can see the result is 3, right? So now I hope you understood the basically the solution. Now I will show you the code where I have implemented this algorithm into the C++ code. So let's understand the code here. So basically here this is our main function, right? In main function I am just taking the input from the user itself for the use case count, and then for the matrix, right? And then I am calling this one, this is for the printing the grid function, right? It will basically to verify the helper function kind of. And here we have x shape recursive, so this will count the shape, how many shapes we have in the grid, and it will give me, right? And it is having one helper function here, update connected x shape to O. right? So that is what we discussed, right? We are making all the visited to O basically here, right? And we are here traversing all the each and every node of the grid, right? So if so here we are like this is kind of row and this is for the column here. And here if we see the particular position, we have the X. In that case, we will check all the connected nodes to that X value, correct? If it is O, then we will not consider, we will not care of the, we will not basically consider the O, correct? So let me and here for updating I am using the recursive algorithm here basically. So I am here going the right side, this is for right, this is for left, this is sorry, this is for right, this is for down, and this is for left. Here I am doing j minus 1, and this is for here up, right? I minus 1, I am going up, correct? So four direction I am checking here, and before that initially I am updating the x value to O of the current node. So let me build it and then we will run it. So build is done. So let's run this one. So it is asking for the use case count. So let's take use case count is 1, right? It is asking the size of. So we took the example of 3 cross 3. So let's go with that only, 3 cross 3. Then please enter the matrix elements, right? So matrix elements are like X, O, X, right? And then we have the example here X O X, then O. So we can go this way also. Then we have O X O. Then we have the 3x, right? See here. So this is the grid we entered, and here shape count is 3. Correct. I hope you understood. Let's take another example here. So this time let's take the two use case. Correct. Enter 3 cross 3, or you can say 2 cross 2. Here this time what we will do, 2 cross 2, and here just x, right? X cross x, right? So this is I am taking here. So this is the given basically grid x cross x cross x, and here you see only one shape. Why one shape here? Because in case of x cross x here, right? This is x cross x, right? Yeah, 2 cross 2 matrix, right? All the having x. Why one we are getting? Because see, this is connected to this one, right? And this is connected to this one, and this is connected to this one, and this is connected to this one. So all the x are connected to each other, either horizontally or vertically. That's why we are getting the one result here. So now take another example here. Please enter matrix size. So let's see, matrix size is one, right? One row and three column. Consider this one, right? And here we have x uh, O x. So see here how, so what should be the result here? It should be the result 2. See, shape count is 2, because the first x is making one shape and second x is making one shape. So I hope you understood this one. I have explained you the code, right? I have explained you the algorithm, and we did the dry run also, and we did the code run also. So if you like the video, please press the like button, share it with your friends so that they can also get benefited by this one. And if you have any alternate solution, any alternate algorithm, any alternate approach, and any idea, any suggestion, so please comment below the video. Yeah, so that's all from my side. See you next time. Till then, keep learning and keep exploring.